Hello and welcome to My Secret Math Tutor. For this video, we want to work on finding the derivative of a function at a point using our calculators. And for this particular video, I'll be using my Ti-84, but you could also use it for a Ti-83. Okay, so remember that when we're looking for the derivative of a function at a single point, we want to know the slope of that tangent line. And the good news is the calculator already has a function built in that will give us the slope of that tangent line. Okay, so let me go ahead and grab my example problem and go ahead and grab your calculators. Okay, so the very first thing that we need to do is get that function into the calculator. So go to your y equals screen and go ahead and start typing it in. So I have 1/8 x plus 7, x plus 1, and x minus 4. Okay, so it looks like I have that all typed in. Also double check that your window is set from, say, -10 to 10 on the x's and -10 to 10 on the y's. All right, let's go ahead and press our graph button. Take a look at this function. Okay, so we have a wonderful curvy cubic function, and now we can start finding the derivative at some specific points. So in the first one, I want to figure out what is the derivative at the value of 4. Now if I look closely here, so 1, 2, 3, 4, it looks like it's increasing, so I should be getting some sort of positive value. All right, let's have the calculator find that value. Above your trace button, it says calc in usually different colors, so press your second button and then that trace button. And you get lots of different options. You want the sixth one that says dy dx. That is for your derivative. So scroll down and select it and press enter. Okay, now after this point, the calculator wants you to give it some sort of value wherever you're looking for that derivative. So I'm going to type in the number 4 here. So that little x equals 4 shows up. Then I'll press enter. So it looks like it's giving me the value of 6.8750001. Sometimes it goes through a numerical method where it's just estimating that limit. So I'm going to chop this off and say 6.875. All right, let's do another one of these. Let's find the derivative at -3. So this is on this part of the function. You can see that it's decreasing, so we should get a negative number. So second, calc, go all the way down to dy dx, press enter, and let's give it that value of -3. So type in -3, so x equals -3, yep, that's good. Press enter, and it looks like this is giving me the value of -2.75. There we go. Awesome. Now, every once in a while, you might want to work backwards. In other words, what value would the derivative equal 0? Well, for our particular function, it looks like it would happen in two different spots. Say either at this little local maximum or at that local minimum. Now, unfortunately, you can't just type into your calculator here, hey, find where the derivative is equal to 0, but you can use this feature to kind of estimate where that is. So let's take this first one. So I noticed that this minimum, it looks like the derivative is equal to 0, maybe somewhere around 2. And I can check if that is the case by actually just checking its derivative there. So I'm going to second calc, selecting the derivative, and let's see what the derivative is at 2. So x equals 2. You know what? It's pretty close to 0, but not quite. But if I was just trying to ballpark and say it kind of looks like the derivative is 0 at 2, this might be a good estimate. All right. If you want to find the exact value of where it equals 2, then you want to use, say, the maximum or the minimum function. So let's say I'm going to go to second calc, and that little bottom part, it looks like it's a minimum. So I'm going to select number 3 for minimum. And now I have to give it a few other values. So this minimum point, it looks like it's somewhere around 2. I need some point on the left side and on the right side of 2. So let's select 1 for our left bound. So x equals 1 for the left. And let's select 3 for the right bound. And our guess somewhere in between, let's go ahead and put that 2 in for our guess. So the computer will work for a bit, and it comes up that the minimum is somewhere around 1.8, maybe about 1.85. So we'll put that in as the place where our derivative is about equal to 0. Okay? So if you just want to directly compute what the derivative is at a point, you got a nice function for that, and it'll give you a good estimate. If you want to work backwards, then oftentimes you have to think of some other tools that will actually give that to you. Okay? So hopefully that helps out. If you want to see some more math videos, please visit mysecretmathtutor.com.